Okay, so today we are looking at the core practical. Now, it's unclear, as I mentioned earlier before we were interrupted in our lesson, we don't know really what the government are saying about the exams, but I do know that there has to be some kind of internal exams that we base our judgment on. And obviously, we have to base our judgment on your effort and commitment, which all of you have shown fabulous commitment this morning with our several hijackers. Now, that means we have to continue to go over the core practicals, even though they might say that, oh, there's going to be no questions on core practicals, but we've only got a few left. So today's core practical is investigating density, right? The do now, right, is here. So which of these materials would float and which would sink? So a small van can carry a volume of 2.5 meters cubed. Its maximum load is 600 kilograms. Calculate the maximum mass or volume the van can carry of each of the different loads in the table. The first one has been done for you. So I need you to have a go at these calculations, just sketch out the table, right? I'm going to give you 3 minutes, right? So I'm going to give you 3 minutes. So the timer on our little rundown is currently 13:50, and we're going to give you to 16:50 to have a go at those calculations. So everyone have a quick go. Off you go. Can you all hear me now? Is that better? Okay, so, right, let's try again. So, now we've done this, right, let's have a go. So we're going to start off with Maria. Maria, tell me the definition, write it in the chat, because remember I can't hear you, the definition for density. Not the definition, sorry, the formula for density. So density equals what? Write it in, please, Maria. Don't Google it. It was from Thursday's lesson. So Thursday's lesson. Density equals mass times volume. Is she right? Right? I don't think so, unfortunately. Right, so density equals mass divided by volume. So divided, we need that like little slash one. So what we should have done then, right, is, so if we have a little look. So on here, it says calculate the maximum mass or volume that can carry. So as with all things we've talked about, so if you've got a formula triangle, right, so we need two of the components. So we need to first of all assume, right, that each of them carries the maximum mass, right? So the maximum load it can carry is 600 kilograms. So if I put 600 in each of these, I can then work out the maximum volume, right, that it can carry. Okay, so for the maximum volume, right, for the bricks, it would be 0.3. So 600 divided by, because mass divided by density divided by 2000. Right, pine wood would be 600 divided by 420, so that'd be 1.43. And then for balsa wood, 600 divided by 160 would be 3.75. That answer, though, would not be right, because remember, it said in the PowerPoint that the maximum load, sorry, the maximum volume was 2.53. So because that 2.53 is bigger, sorry, is smaller than the 3.75, that isn't going to work. So you have to try again. So you have to put 2.5 as the maximum volume here. So therefore its maximum mass would be 400. So the correct answer here was 600 and then 0.3, 600 and 1.43, and then 400 and 2.5. So as we mentioned, this is the formula triangle. So density is mass divided by volume. Mass would be density times volume, and volume would be mass divided by density. Now, in this one then, so we've got densities of a solid. So how can you find the density of a solid? So to find the density of a solid, you use the following method. So first of all, you would find the mass of a solid by writing the name of the material and the mass of the object in a table. Right? You would then stand a displacement can. Now, this displacement can also be called a eureka can, right, on the bench with its spout over a bowl. You would then fill the can with water until the water just starts to come out of the spout. So if you have a look here, so the water would be just at this level here, so just before it comes out the spout. You will then hold a measuring cylinder under the spout and carefully drop your object into the can. If your object floats, right, you would carefully push it down until it's completely under the water, because the whole object has to be under the water. Your finger should not be in the water, because otherwise that would displace some water as well. You would stand the measuring cylinder on the bench and read the volume of water you have collected. Right, this is the same as the volume of the object. You would then write the volume down. So to work out its density, you would then use the mass that you measured at the beginning, the volume that you measured at the end, to do mass divided by volume, and then you would get the density of that object. Okay, now there is a video to watch, but as we mentioned earlier, when we looked at the biology one, the video didn't quite work, so we're not going to do the video. I'm going to put it on the link on the VLE in a little bit. Okay. Right, so part 2, how can you find the density of a liquid? So for the density of a liquid, you would put an empty beaker on a balance and you would zero the balance so that the beaker is not affecting its Oh, Jamil, I'm half agreeing with you. This has gone madness. Madness. Right. Okay. Let's go back. I'm losing the will to live. Absolute madness, Nabil. I agree. I can't believe this. I agree. Right, view lobby. Where's Abbas gone? Right. Okay. Abbas, did someone kick you off or did you join? Right. Abbas, did you get kicked off or did you accidentally leave? Can you pop it on the chat? Abbas, I've just let you in. Right. Okay. Right, Abbas, did someone kick you off or did you accidentally leave? Just so I can see if this is even working still. Husband, your face, your profile is literally what my face is doing right now. I'm just getting so sick of it. I'm like, oh my God. What? Right, Abbas, are you there? Right. Okay, right. So at least we know that Abbas did not get unmuted. Right. Okay. Let's start again. So we were here. Right, this was your do now. Right, you can see I've already ticked and crossed. So let's just erase these very quickly. Right, okay, so hopefully now everyone can hear me. Hopefully now no one will accidentally kick themselves off and it will work. Right, okay, so right, in this calculation, a small van can carry a volume of 2.5 meters cubed. Its maximum load is oh right, okay. I'm giving up, kids. I'm giving up again. I'm just losing the will to live. Right. I hope you can hear me now. I will find out what is happening. A mini breakdown at home. And post these videos recorded a bit.